Welcome students. Myself Dr. Govardhan Yadu, Assistant Professor Physics, Government Graduation College, Rajim. Today I will deliver a video lecture on helium neon laser. In my previous video, we had discussed about the ruby laser. Ruby laser is a solid state laser, but the output of ruby laser is discrete. That means it cannot be used in experimental purpose. So there are number of lakes of ruby laser which can be resolved by the helium neon laser. Helium neon laser is an experimental laser. It is continuous, so it is used in a different purpose of human beings. In a medical reason, we can done the bloodless surgery. In the defense region, we can use in BrahMos, in knock tanks and other defense equipments. In the communication system, they can also be used in different purpose. So let us start with the helium neon laser. In this lecture, we again discuss the laser in three parts. The first part is the component part, and the second part is the construction part, and third part is the working principle. So in the working principle, we can discuss about the energy level diagram of a helium neon laser. So let us see the component of helium neon laser. Basically, there are three components of helium neon laser. Active medium. Here, the active medium is a combination of helium and neon gases. So we can use a mixture of helium neon gas with 10:1. So out of 10 helium atom, we can use only one neon atom. Why we can take helium neon laser? The answer is that some of the metastable state of helium atoms are approximately equal to the metastable state of neon atom, or in other words, the helium and neon excited stable states are equivalent to each other. In the experimental point of view, the energy state of helium is almost the metastable state, and the value of that state is around 19.81 electron volt and 20.66 electron volt. That will be discussed in later in this video lecture. So here the active medium is a mixture of helium neon laser. Helium is the host material and neon is the active center. So that laser transition can be occurred in the neon atoms. So neon atom is totally responsible for the lasing process in the helium neon laser, but the helium can very well support to the neon atomic energy states. Helium is the lightest compared to the neon, so they can easily excited by the electrons. So in the construction part, we can see that there is a glass tube. Inside it, the mixture of helium and neon can be situated, and the left part of the glass tube, there is a parallel plate. And right side of the glass tube is also a parallel plate. This makes the second component of a laser, which is called resonant cavity. The left parallel plate is partially silvered, partially reflector, and the right part of the glass tube is totally reflector. So here the glass tube where the helium neon mixture is contained itself behaves like a resonant cavity. The ends of a glass tube made as a total and partial reflector. This becomes the resonant situation, resonant arrangement. So the the glass tube contain helium neon mixture and the reflectors, and that helium neon mixture tubes connected with the DC power supply. Here we can see that the cathode is connected with minus sign and anode is connected with plus sign. By this DC power supply, we can introduce the electrons in this helium neon mixture. So there is a possibility to interact electron with the helium and neon gas particles. Helium is the lighter atom, so the electron can interact helium easily and excite to the helium atom, and helium atom can be undergo to their excited state, which can be seen in the working principle that can be seen in the energy level diagram. So here the third part is the DC power supply, which is the pumping process. Here the pumping process is the electrical pumping. In case of ruby laser, we can use power supply. That can also be the that can also produce a flashes of light in the helical xenon tubes. But here the DC power supply is directly connected to the helium neon mixture by the anode and cathodes. So the electrical pumping is working on this substance. So the three components of helium neon laser is drawn in this figure. Inside the glass tube, helium neon mixture, which is the active center and active medium, and the reflectors on both sides of the glass makes as a resonant cavity, and in the pumping process DC power supply can be used, which is connected directly to the helium neon mixture glass tube. So this is the part of helium neon laser, active medium, resonant cavity and pumping process. So we can see the energy level diagram of the helium neon laser. This is the first laser obtained experimentally in 1960 by the Ali Jaman, and it is a 4-level system instead of ruby laser. Ruby laser is a 3-level system, but here this is the 4-level system and gaseous electron type laser. So we can see the energy level diagram of helium neon laser. This is the helium energy states. Now we can represent as this is E0. E0 is the ground state of helium neon laser, and this one is called E1 and E2 of the helium, and this one is called E1 prime, this is called E2 prime, this is called E3 prime, and this is called E4 prime, and this is called E5 prime. Now each of the energy level of a helium neon laser can be nominated as E0, E1, E2, E1 prime to E1 prime, and so on. Here the ground state of helium atom interact with the electron and excite and formed the energy level. This E1 and E2, which is correspond to 2,3s and 2,1s levels. So this energy, this transition comes into the picture because of the collision of electron through the helium ground state particles. So this is the process of collision. Now we can said earlier the metastable state of helium and neon is almost equivalent. So the E1 and E2 of helium excited state is approximately equal to the E3 prime and E5 prime of the neon atom, which is approximately equal to 19.81 electron volt, and this one is the 20.66 electron volt. So in physical way, we can say that the collisions occurs in between the similar energy states. So this helium excited state is almost the metastable state. So the particle from in this state E1 and E2 doesn't come to the ground state by the spontaneous emission, because these are the metastable state. Here the metastable state are lifetime 10 to the power minus 3 seconds, which can be discussed in earlier video lectures, and the unstable excited state, the lifetime is 10 to the power minus 8 seconds. But here in case of helium, the excited states are metastable and the lifetime is 10 to the power minus 3 seconds, which is 10 to the power 5 times greater than. So the excited helium particle lose their energy when the excited helium particle interact with the ground state neon particles. These particles interact with the ground state neon particle and provide some energy to the neon ground state particle and stimulate the neon particle to form the energy levels E1 prime, E2 prime, E3 prime, E4 prime and E5 prime. So after interaction with the excited helium to the ground neon particle, this energy state can be drawn. So the transition becomes E5 prime to E4 prime, and this is the 1s, 2s and 3s levels of neon, and these are the 2p and 3p levels. So from the 3s to 3p level, 3.39 micrometer wavelength can be emitted, and from E2s to 2p this corresponds to 1.15 micrometer, and E3s to 2p this corresponds to 6328 angstrom. Here the energy transformation by the collision of excited helium to the ground state neon atom. So there is a maximum probability to interact electron with the ground state helium atom and the excited helium atom to the ground state neon atom. To increase the probability of interaction of the particles, the tube of helium neon laser made narrow. When the tube made narrow, there is a maximum possibility to interact electron to the helium and neon and excited helium to the neon ground state particles. So here from E0 to 3S1 and 1S1 comes from the collision of the helium ground state particle to the electron, which comes from the DC power supply, and this figure also indicates that the ground state helium atoms interact with the excited state of neon atom. Here also the collision can transfer the energy from one energy state to another energy state. So the laser action can be obtained by the neon energy states. Now here we can see that from the level 3s to 3p, 3.39 micrometer radiation emits from the system, which correspond to infrared region, and also from 2s to 2p again 1.15 micrometer radiation emits, which also correspond to infrared region. But from the transition 3s to 2p, which correspond to 6328 angstrom, which is correspond to visible region. So in case of helium neon laser, we can obtain infrared radiation as well as the visible radiation. And from 2p to 1s, 6000 angstrom emission can be obtained by the spontaneous emission. So 3s to 2p and 3s to 3p and 2s to 2p are the transition correspond to stimulated emission. Here we write the transition separately. 3s to 3p, 3s to 3p ये 3.39 micrometer, and 3s to 2p 6328 angstrom, and 2s to 2p, this correspond to 1.15 micrometer, and 2p to 1s, this correspond to 6000 angstrom. This first three transition obtained by the stimulated emission. And last one correspond to spontaneous emission. Why first three is called stimulated emission transition? Because these states are the metastable states, and these states are also the metastable state we discussed in earlier. So from the metastable state, the particle doesn't lose their energy by the spontaneous process, by the self emission process. It is only possible to emit light from the particle by the stimulated emission in the metastable state. So we can say that from the transition 3s to 3p, 3s to 2p, and 2s to 2p correspond to stimulated emission, and this emission begins the laser light pulse, because in the laser process we have to need a prominent stimulated emission. As I discussed in previous lectures, in the dominant laser pulse, stimulated emission can be maximized, stimulated emission can be enhanced. So when the stimulated emission can be enhanced in any light source, that light source can become the laser light source. Here the 6328 angstrom, that is the wavelength of a laser light emit from the helium neon laser. It is in visible part and which correspond to red color. So from the helium neon laser we obtain a laser pulse of red color. In between the levels from 3s, 2s and 3p, 2p, the population inversion can be achieved in between these levels. So the particle in 2s and 3s level are maximized at a time with respect to 2p and 3p levels, and these two levels, 3p, 2p level, lose their energy by the spontaneous process, because these are not the stable energy states. So from this state, here we can see that 2p to 1s, 6000 angstrom emission can be obtained by the spontaneous process. And from 1s to E0, there is also transition 1s to E0. This comes because the particle in 1s state lose their energy with interact with the walls of a tube or the interaction with the other atoms. So there is no emission can be obtained from this interaction. So possibly the energy level diagram of a helium neon laser is very complicated, but the way of understand the transition from helium to neon and neon to helium, which is very interesting. The helium neon laser can be used in different areas of medical science, communication systems and defense action, in photography and other areas, because this is the continuous laser system and it is experimentally proved laser system. In the bloodless surgery, helium neon can be used in the NAC tank in defense, BrahMos, that can also be used helium neon laser. So there are number of advantages of helium neon laser. The disadvantage of helium neon laser is the intensity of helium neon laser is very low, but the efficiency is very good. So the helium neon laser can resolve the lack of ruby laser. Thank you very much.